Hi, Assalamualaikum. In this video, we are going to do all questions from self-exercise 8.7, topic of kinematics of linear motion. Okay, question number 1. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 3 meter per second. Its acceleration a meter per second squared t seconds after passing through O is given by A equals to 6 minus 3t. Okay, find the instantaneous displacement. Okay, so now the relation between the displacement, velocity and acceleration. S to V, differentiate V to A, differentiate A to V, integrate, and V to S, integrate. Okay, so now we are going to find displacement, meaning that from A to find displacement, we need to integrate twice. Okay, find V first. V is integrate acceleration 6 minus 3t with respect to t. So now V equals to 6t minus 3t squared over 2 plus c. Okay, now given initial velocity is 3. So when t equals to 0, V equals to 3. Okay, so then we substitute V is 3, T is 0, minus 3 over 2, 0 squared plus C. So then C equals to 3. Okay, so therefore V is 6T minus 3T squared over 2 plus 3. Okay, this is function of velocity. Okay, now to find displacement, we need to integrate another time. So S is integrate 60 minus 3t squared over 2 plus 3. Okay, with respect to t. Okay, so then this one S is 6t squared over 2 minus 3 over 2 t cubed over 3 plus 3t. Okay, plus c. So now no information given, so we assume c is 0. Then when t equals to 0, s equals to 0, then c equals to 0. Okay, so then finally s equals to, this one we can simplify, 3t squared minus t cubed over 2 plus 3t. Okay, this is the function of displacement. Then for question A, okay, for question A, we need to find the instantaneous displacement when t equals to 5. Okay, so A, when t equals to 5, substitute 5 into displacement, which is S. So S equals to 3 times 5 squared minus 5 cubed over 2 plus 3 times 5, okay, which is equals to 27 1 over 2 meter. Okay, meaning that when t equals to 5, the particle is 27 meter and half to the right of point O. Okay, so B, find the displacement when its velocity is uniform. Okay, so B, uniform velocity. Okay, with uniform velocity, A equals to 0. Okay, when A equals to 0, this is a function of A. Okay, so 6 minus 3t equals to 0, then t equals to 2. Okay, we are going to find displacement, substitute into displacement. So S equals to 3 times 2 squared minus 2 cubed over 2 plus 3 times 2. Okay, which is equals to 14 meter. Okay, so meaning that when the velocity is uniform, the particle is 14 meter to the right of point O. Number 2, acceleration a meter per second squared for a particle moving along a straight line t second after passing through a fixed point O is given by A equals to 12t minus 8. Okay, given the velocity of the particle t equals to 1 second after passing through O is negative 10. So meaning that when t equals to 1, v equals to negative 10. Okay, find the instantaneous displacement in meter of the particle when acceleration is 4 and particle is at rest. Okay, first of all, you need to find displacement. So SVA, okay, this one, differentiate V to A, differentiate A to V, integrate V to S, integrate another time. Okay, so now given acceleration, okay, to find displacement, we need to integrate twice. Okay, so first find V first. So 12t minus 8 integrate with respect to t. Okay, so V equals to 12t squared over 2 minus 8t plus c. Okay, so now when t equals to 1, V equals to negative 10. So this one negative 10. This one simplifies 6 times 1 squared minus 8 times 1 plus c. Okay, so then c equals to negative 8. Okay, so therefore V is 6t squared minus 8t minus 8. Okay, so this is function of velocity. Okay, to find displacement, okay, integrate another time, function of V. Okay, with respect to t. So then S is 6t squared over 2 minus 60 cubed over 3. Okay, so minus 8t squared over 2 minus 8t plus c. Okay, so since of no information given, so we need to assume c equals to 0. So when t 0, s 0, c 0. Okay, so therefore s is this one simplify 2t cubed minus 4t squared minus 8t. Okay, this is function of displacement. Then to answer the question, find instantaneous displacement when acceleration is 4. Okay, acceleration is 4. This is acceleration. So to answer question A, acceleration is 4. Then 12t minus 8 equals to 4. 12t equals to 12t equals to 1. Okay, so then substitute t equals to 1 into displacement. Okay, so displacement is this one. So S equals to 2 times 1 cube minus 4 times 1 squared minus 8 times 1, which is equals to negative 10 meter. Okay, meaning that when acceleration is 4 meter per second squared, the particle is at 10 meter to the left, because negative to the left of point O. Okay, B, find the instantaneous displacement when the particle is at rest. Okay, at rest, V equals to 0. Okay, so B at rest. Okay, V equals to 0. Okay, just now we already have V. V is 60 squared minus 80 minus 8 equals to 0. Okay, from the previous one. Okay, so this one. So this is V, 60 squared minus 80 minus 8. So this one equals to 0. Okay, so then we can, this is quadratic equation, so we can factorize. So 2, 3t squared minus 4t minus 4 equals to 0. Then 2, this one 3t plus 2, t minus 2. Okay, so now we got t is negative 2 over 3, t equals to 2. Okay, so now t is time. Okay, time always positive, so we need to choose t equals to 2. Okay, so to find displacement, we substitute t equals to 2 into displacement. Okay, so S is 2t cubed minus 4t squared minus 8t. This one, okay. So S is 2 times 2 cubed minus 4 times 2 squared minus 8 times 2. Okay, which is equals to negative 16 meter. Okay, so meaning that when the particle is at rest, the particle is 16 meter to the left of point O. Next, question number 3. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 8 meter per second. The acceleration 8 meter per second squared at t seconds after passing through O is given by A equals to 10 minus 60. Okay, so find the maximum displacement. Okay, so now we need to find displacement. Okay, so as VA, this one, differentiate V to A, differentiate A to V, integrate, V to S, integrate. So then, to find displacement, we need to integrate twice. Okay, so then find V first, integrate 10 minus 60 with respect to t. Okay, so V is 10t minus 60 squared over 2 plus c. Okay, now given initial velocity 8. So meaning that when t equals to 0, V equals to 8. We substitute into the function of velocity. So t is 0. So this one we can simplify 3 times 0 squared plus c. So then c equals to 8. Okay, so therefore V is 10t minus 3t squared plus 8. Okay, so this is function of V. Now to find displacement, we need to integrate another time. So S equals to integrate 10t minus 3t squared plus 8. Okay, so with respect to t. So S equals to 10t squared over 2 minus 3t cubed over 3 plus 8t plus c. Okay, so then we assume c equals to 0 because no information given. When t equals to 0, S equals to 0, then c equals to 0. So S is, this one simplify. So 5t squared minus t cubed plus 8t. Okay, so this is function of displacement. To answer the question A, okay, find the maximum displacement of the particle. Okay, maximum displacement, okay, maximum displacement, maximum S. So V equals to 0. Okay, this is V. Okay, so we make it equal to 0. We rearrange. Here we will get negative 3t squared plus 10t plus 8. Okay, equals to 0. Okay, so this is quadratic. So negative 3t squared minus 10t minus 8 is 0. So negative 3t t plus 2 minus 4. Okay, then t equals to negative 2 over 3. T equals to 4. Okay, we choose t positive because t is quantity of scalar, always positive. So we need to find the maximum displacement. Okay, we substitute into displacement. Okay, so when t equals to 4, S equals to 5 times 4 squared minus 4 cubed plus 8 times 4. Okay, which is equals to 48 meter. Okay, so B, the distance traveled by the particle in the 5th second. Okay, so B, distance traveled in the 5th second, meaning that from t equals to 4 to t equals to 5. Okay, so then we substitute t equals to 4 and t equals to 5 into S. Okay, into function of displacement. Okay, so now when t equals to 4, S equals to, now we already have 48. When t equals to 4, S 48 meter from previous question. Okay, when t equals to 5, s equals to 5 times 5 squared minus 5 cubed plus 8 times 5. Okay, which is equals to 40. Okay, so now then distance traveled by the particle in the fifth second is, okay, distance travel is 40 minus 48. Okay, since of distance, we just put modulus, which is equals to 8 meter. Question number 4. Farhan participates in a cycling event organized by a cycling society. Farhan is cycling along the straight road. At the hours after passing the starting point, its acceleration a kilometer per hour is given by A equals to 40 minus 16. And his starting velocity is 30 km per hour, meaning that when t equals to 0, v equals to 30. Okay, so starting velocity. Okay, A express the acceleration function as, okay, actually this one the displacement, because acceleration actually we already have, and the velocity function v in terms of t. Okay, so s va, S to V, differentiate V to A, differentiate A to V, integrate V to S, integrate. Okay, so now we are going to find displacement and velocity. So we need to find velocity first. So velocity integrate acceleration. So 40 minus 60. 16. Okay, so with respect to t, so v is 4t squared over 2 minus 16t plus c. Okay, so then the initial velocity 30, so c is 30. So v 30 is 2 0 squared minus 16 0 plus c, so c is 30. Okay, so then v is 2t squared minus 16t plus 30. Okay, so to find acceleration, we need to integrate another time. So then s is integrate 2t squared minus 16t plus 30 with respect to t. Okay, so this one 2t cubed over 3 minus 16t squared over 2 plus 30t plus c. Okay, this is function of s. Okay, so since no information given, we assume c0. Then when t0, s0, c equals to 0. So s is 2 over 3 t cubed minus 8t squared plus 30t. Okay, this is function of displacement. Question B, prove that Farhan stopped instantaneously when t equals to 3. Okay, so stop. Okay, v equals to 0. Okay, just now from question A, this is v. Okay, 2t squared minus 16t plus 30. Okay, so when v equals to 0, meaning that 2t squared minus 16t plus 30 equals to 0, quadratic. So we factorize 8t plus 15. Okay, so this one 2t minus 5, 3. Okay, so now we got t equals to 5 and t equals to 3. Okay, so proven. Okay. Question C. Find the total distance traveled in kilometer by Farhan in the first 3 hours. Okay, so meaning that from t equals to 0 to t equals to 3. Okay, so actually to find total distance by Farhan, we need to test v equals to 0. Okay, v equals to 0, we already have. Okay, this one t equals to 3. So just at that time. Okay, so now meaning that is not affect the movement of Farhan. Okay, so then we substitute t equals to 0 into displacement. Okay, just now displacement is 2 over 3 t cubed minus 8t squared. plus 30t. So we substitute t equals to 0 into s and t equals to 3 into s. Okay, so when t equals to 0, okay, s equals to 2 over 3, 0 cube minus 8 times 0 squared plus 30 times 0 equals to 0 kilometer. Okay, so when t equals to 3, s equals to 2 over 3, 3 cube minus 8 times 3 squared plus 30 times 3. Okay, which is equals to 36 kilometers. So then total distance equals to 36 minus 0, which is equals to 36 kilometer.